All right, so guys, looking at today's lesson, yesterday we talked about surface water and what affects runoff. And then where does all that runoff go? To lakes and streams. Okay. So what we're going to look at today is how streams actually get rid of all that extra runoff. And we're going to look at the processes that go into streams. Now, to me, this is one of the cool activities, or not really activities, but one of the cool lessons of the year. Because not so much from the different things that we get to do with this, but it's one of those things that you guys can actually take home, and you will probably, although I doubt any of you will admit it, you will refer back to this quite often as you're driving down the road. Because there's lots to see out of today's lesson and understanding how streams work and why they work the way they do. So first what I want you guys to do is I want you to take 2 minutes, work with your partner, and I want you guys to compare and contrast the two streams that you see here on this board. And we're going to come back together, and we will share those, comparisons, and we'll explain why those comparisons exist. So please take 2 minutes and develop your list. All right.
I know.
Oh, good. Tanner has something to share.
The one on the left is very calm and easy flowing, and the one on the right is pretty rapid.
Okay, so let's write that one down. So the one on the left is very calm,
The one on the right is
and the one on the right is very rapid. I guess, hold on. So we have calm versus rapid. Okay, Coleman?
The one on the right has a deep slope,
Okay, so this is definitely steep, and this
One.
is,
like no slope.
yeah, very flat. Okay, Dakota?
Comparing them, I'd say that they're both near forests.
Okay. So we still have some vegetation, right? Vegetation involved. Go ahead, Dakota.
One you can see seaweed in, one you can't.
Okay, say that again.
One you can see seaweed and dirt and stuff in, one you can't.
Well, that's not seaweed. What that is, that's a reflection of the trees up here.
I think
So that's not. It's actually a reflection.
Not that, like all that.
We're talking about the lily pad.
Oh, well, those are rocks, not necessarily seaweed. Okay, guys, some other things we noticed. Yeah, we haven't heard from you on this yet. One's wider than the other.
What did you say?
Well, hold on to that. Where'd that go? All right, so which one's wider?
the one with the bushes.
The one with the bushes. All right, so that's wide. This is very narrow. Good. That means, hey, good news is we're passing Sesame Street at this point.
Oh, okay.
Calm
Small.
and rapid. Learning our opposites today.
Yay!
Okay, now,
One's a lot deeper than the other.
which one do you think is deeper?
That's Jim's.
I'm feeling
What are you?
One on the left.
Right would be the deep one, but
I guess the one on the right's deeper?
Looks like it's about to meet, so I'm gonna, like the two.
I think the one on the left is probably 10 times deeper than the one on the right. I will bet money.
I think it's definitely too close to call. I think it's hard to tell.
I was right.
But we should expect that this left one would be deeper. We'll explain why that is here in a little bit. All right, so any guesses why these are the way they are? Why don't we have a wide channel on the one on the right?
That's how steep it is.
What do you mean?
Hasn't broken down. Like the steep's like that, so it's just gonna keep on going fast now.
Okay, there we go. All right, so because of the steepness of the stream channel, the gradient, we're going to be down cutting. That's literally what's happening here. Is the stream? And if you guys can actually see the top of that valley, see the top of here. That's where the stream started. And what it did is it down cut through the rock. This is very similar to if you have a handsaw and you're trying to cut through a piece of wood. It's down cutting at an angle in an effort for this level to reach its base level. So that might be something we should talk about right now. When you think about a stream simply follows the gradient until it reaches basically an ocean or a basin. This is what we call base level. It's the lowest point that the stream can go. If it goes below that, then the stream can't empty into the basin because water is not run uphill. So this is base level. So the whole point of the stream is to basically get every single point along its path to be at base level. And so what it does in an attempt to do that is it down cuts through the rock, trying to get down to base level. And this is one of those themes. Remember, we're talking about the essential themes of earth science. We said that everything's trying to reach equilibrium. This is a perfect example where, in nature, streams are trying to reach the equilibrium, which is base level. That's the equilibrium of the stream. Okay, so stream, basically, they down cut through the rock, trying to get down to base level. Now, remember yesterday we talked about what happens when you have a narrow channel? Remember talking about that? The water flying down. Remember the tube that we had yesterday? With a very fast-moving water down the tube. What happens as soon as we hit open space?
Spread out.
It's spread out. So notice, how does the width of this stream, now we've hit open space, what happened to the width of the stream? How does that compare to over here? Okay, it's much wider because it's got a lot more open space. Therefore, it's still flowing the same discharge, but it's doing it over a wider area, so therefore it can actually travel slower. And so that's kind of the nice thing with that. Also, one of the things that you guys should notice is a lot of times with streams, what shape is this valley over here on the right? If I ask, yeah, perfect. If I was going to ask you to give me a profile, they're V-shaped valleys. Okay? Anytime you have a V-shaped valley, that's indicative of a valley that has been downcut by a stream.